This is Math Command. If this is the first time you are joining my live stream, make sure you subscribe and turn on the notification bell so the next time you miss the update. In today's lesson, we are looking at logarithmic equation. We have the equation which is log 2 to the power x plus 1 plus x plus log 2 to the power 5 minus x, which is equals to 3, plus log 2 to the power x minus 2. So without wasting much of your time, let's get started. For solution, we have to start with the question 1 first, right? We have log 2 to the power 1 plus x, then plus log 2 to the power 5 minus x, which should be equals to 3 plus log 2 power x minus 2, right? The most common important thing when you're dealing with logarithmic equation, you have to check if you have the same base, that means you are going to go direct. And the laws of logarithm opposes the laws of indices. Or let me say a logarithmic equation is associated with the indices. If here you have a positive in indices, whenever you're having a to the power 9 multiplied by a to the power 2, this one should be equals to a to the power 9 plus 2. The logarithmic do the opposite way. Whenever, because here in the powers we have a positive, logarithmic do it in the opposite way. Here we have a positive, so that means we are going to multiply the powers. So these are the powers of logarithmic equation, and these are the bases. It does the opposite way, right? Then in which here we are going to only get only one common logarithm because we have log 2. So we're going to say log 2 to the power 1 plus x in the bracket, then you multiply by, because there's a positive, so you multiply by 5 minus x, right? Then when this term crosses the cosine, here there's a positive, so it will be minus log 2 to the power x minus 2, right? Which should be equals to 3. Here we have only remain with the 3, right? Then here comes also, we have a negative. Here it was a positive. So whenever you're having a negative, so that means you are going to divide. We are going to follow the laws of indices because the laws of logarithmic opposes the law of indices. So if you have a to the power 4, you divide by a to the power 3. This one should be equals to a power 4 minus 3, in which in logarithmic equation 4 minus 3, it is in the base, and this one it is the power. So we are going to multiply, we are going to divide a divided by this one. So we are going to divide this term divided by this one here, in which we are going to only correct the one base, so one logarithm, because we are having log 2. So log 2 the power, let's combine this one. 1 times 5, you're going to have 5. Then 1 times x, you're going to have minus x. Then x times 5, so you're going to have plus 5x. Then x times minus x, you're going to have x squared in the bracket. And then you divide by this term which we're having here, which is x minus 2, which should be equals to 3, right? And here it comes also, you have to change from logarithmic equation to exponential equation. How do we do that? Let's say if you have a log, 2 to the power 3, which should be equals to, let's say 1. What you have to do here, you have to swap this 1 which we are having, it will become the power of these 2 here, which it will be 2 to the power 1, which should be equals to 3. That's how we change the logarithmic equation to exponential equation. So we are going to do the same even here. So this 3 will come at the top of this one, in which it will be, that's how we can cancel logarithm. So we are going to have 2 to the power. This 3 which we are having here, when this 3 comes here, it will be power 2 to the power 3, which is equals to, we have 5. Then let's calculate here. Minus x plus 5, you're going to have plus 4x, right? Then minus x squared, right? Then we are dividing with x minus 2, right? In which 2 to the power 3, it is 8, which should be equals to 5 plus 4x minus x squared, right? Over x minus 2, right? Then here you cross multiply now. Then in which we are going to have, let's take it here. You are going to have 5 plus 4x minus x squared should be equals to 8, open bracket, x minus 2, right? Then in which here we're going to say 5 plus 4x minus x squared, which should be equals to 8 times 8 times x, we are going to have 8x. Then 8 times minus 2, we are going to have minus 16, right? Then we have to start with this term here. So we're going to say 8x minus 16 to be equals to 5 plus 4x minus x squared. Then what you have to do, if you reach here, we have to take this quadratic equation into standard form. Into the standard form, which I'm saying it is ax squared plus bx plus c. So we are going to do the same here, right? So we are going to say if minus x squared equals to the equal sign to be x squared, right? Then plus 4x, it will be minus 4x, right? Then positive 5, it will be minus 5, right? Then here we have a positive 8 minus 16, which should be, here we have remained with 0, right? Then let's make a space here. So now here we're going to say minus 4 plus 8x. Here this is x. So we are going to have x squared. We're going to have plus 4x. Then minus 5 minus 16. You are going to have minus 21, which should be equals to 0. And this is a quadratic equation now. You can solve either by factorization, by formula, or completing of squares. But here we are going to solve it using factorization. So let's go. We're going to look for product and sum. So the product, it is minus 21, and sum, it is 4. So we are going to look into two numbers. When you multiply, you are going to have minus 21. When you subtract or add, you are going to have 4. So these numbers, we can see it is product, it will be 7 multiplied by minus 3, right? Minus 3. This one should be equals to minus 21. Then when you add 7 minus 3, this is the sum, you are going to have 4. So this is the 4 which we're having here, right? So we're going to substitute now. We're going to say x squared plus this 7 which we're having here, 7x, then minus 3x, then minus this 21 which we're having here, which is equals to 0. Then if you reach here, you have to factorize now. What is common here? It is x, open bracket, x into x squared, you're going to remain with x, and plus x into 7x, you're going to have 7, then close bracket, minus, what is common here? It is minus 3, right? Minus 3 into minus 3x, you're going to remain with x, minus 3 into minus 21, you're going to remain with it plus 7, which is equals to 0. So if you reach here, you have to make sure that this term and this term are equal. We have a positive 7, So this term and this term are equal. So we're going to take this term and this term here. So x minus 3, then x plus 7, then you equate it to 0. So you equate, if you reach here, you have to equate each of each equation to be equals to 0. So we're going to say x minus 3 to be equals to 0, or x plus 7 to be equals to 0. So here we're going to have x equals 3, or x to be equals to minus 7. So these are our answers for this first question here. So now let's move on to the second question. Let's move on to second question. Second question, we have two. We have log 2 to the power y squared, which should be equals to 4 plus log 2 power y plus 5, right? In which here we have log 2 and log 2. So we have to take this term to the left side. So we are going to say log 2 to the power y squared, the power y squared. Then here there's a positive, then here it will be minus log 2 to the power y plus 5, right? Which should be equals to 4. Like I said, whenever you're having a negative here, so that means you are dividing the powers because we have the same base. So you have to get one logarithmic because it is common. So you're going to say log 2 to the power. This one should be divided with it because we have a negative. So it will be y squared over y plus 5, right? Which should be equals to 4. If you reach here, like I said, whenever you're having this kind of question, you should take it into exponential. That's when you can find the value of y. So let's take one of the law of logarithm, which is log 2 to the power 3 should be equals to, let's say here we have x, which is equals to 3. So how do we take this logarithmic equation into exponential equation? So this 3, it will become the power, then this x, it will be a base. So in which it will be 2 to the power 3, it will be equals to x. And x, it will be equals to 2 to the power 3, it is 8. That's how you can find the value of y by changing logarithmic equation into exponential equation. So we are going to do the same even here. So this 4 will become the power of this base 2 here. So it will be 2 to the power 4, which is equals to y squared over y plus 5, right? Then in which, let's take it here, 2 to the power 4, it is 16, which is equals to y squared over y plus 5, right? Then here you cross multiply now. Y times 1, you're going to have y squared, which should be equals to 16, open bracket, y plus 5, right? Then y squared equals to 16 times y, you're going to have 16y, then plus 16 times 5, you're going to have 80, right? If you reach here, this is a kind of quadratic equation. So you're going to say y squared, when 16 crosses the equal sign to be minus 16y, then 80 positive 80 to be minus 80 to be equals to 0. And this is a quadratic equation also. So we are going to solve this quadratic equation using factorization. If you want, you can use a difference of two squares by formula, but me, I'm using factorization. So y squared minus 16y minus 80 to be equals to 0. So we are going to look for product and sum. So in which we're going to say the product should be, let's say we have minus 20 multiplied by 4. This one should be equals to minus 8. Then when you subtract 4 minus 20, you are going to have minus 16. That's what we have here. So we are going to take these numbers into this quadratic equation, in which we're going to have y squared, then minus 20 a minus 20y, then plus 4y, then minus 80, which should be equals to 0, right? Then here you have to factorize now. What is common here? It is y outside. Then y into y squared, you are going to remain with y. Then minus y into minus 20, y, you are going to remain with the 20, the bracket, then plus. Here what is common? It is plus 4, right? Then 4 into 4y, you're going to remain with y, minus 4 into 80, it is 20, right? Which should be equals to 0. So if you reach here, you have to make sure that this term and this term are the same. So we're going to take this term and this one and one of the this term and this term here. So we're going to say y plus 4, then y minus 20, which should be equals to 0. So you equate each of equation to be equals to 0. So we're going to say y plus 4 equals to 0, or y minus 20 to be equals to 0, right? Then y it will be equals to minus 4, or y it will be equals to 20. So these are the values of this second question here. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you miss the new update. The next lesson we'll be looking at one of the logarithmic, let's see, logarithmic exponential equation. Logarithmic, how to change logarithmic into exponential equation. And don't forget to check those upcoming video there, which should be looking at one of the topics in logarithmic equation. Thank you.